All right, so let's try a couple of these GCFs where you have to do the GCF of the number and the GCF of the variable. And that's the way we're going to separate them. You want to look at them separately, right? I mean, the answer is going to be a term that has a combination of a number and a variable. But you want to look at the GCF separately. So let's look at letter A. We're on example 1, right under the word shortcut. And I've given you a couple of examples of how to take out the GCF or how to find the GCF. We're going to take it out in a minute. So for letter A, here are my two terms. First, let's look at the 3 and the 12. Well, what's the largest number that both the 3 and the 12 share? Well, hopefully, if you think about it, you'll realize that it's 3. That's the GCF. For the variables, if you use the shortcut, and it's over there, you can't see it, but you should have it written right there in your notes. The shortcut tells you the GCF of the variable is just the one with the lowest exponent. You got x squared and you got x. X is the lowest exponent, so 3x, this is your GCF right here. It's GCF. The greatest number is 3. The greatest exponent that they share is 1x. They each have 1x. See, this one has 1, that one has 2. They each share 1x. All right, now let's look at letter B. You got the number 5 and the number 10. What is the GCF? Well, you need to think about it. What's the largest number that goes into both 5 and 10? Okay, if you don't know, draw your table. It's 5. The highest number that goes into both 5 and 10 is 5. Now, for your variable, you have an x to the 5th power and an x to the 3rd power. The third is the lowest exponent, so that will be your GCF. They both have 3, right? They both have 1, they both have 2, but that's not the greatest number that they have. They both have 3 x's, so the GCF is 5x cubed, right? Now, letter C, you've got 3x squared and you have 18. Remember that the number that doesn't have a variable is called a constant. So you have 3x squared and 18. They don't both have a variable. You see a variable here. This one doesn't have one. So they don't have the one in common. Do you see what I'm saying? So the GCF for this one is just going to be a number. Because this one doesn't have any variables to compare to. So there isn't going to be a GCF for the variable. So we just need to ask ourselves, what's the GCF between 3 and 18? Well, if you do a little math in your head, whatever, you'll know it's basically 3. So the GCF is just 3. Okay? You getting the hang of it a little bit? I'm taking it fast, but this is elementary school, so it should just be a matter of you sitting down and thinking. I know it hurts. It's painful to think, but eventually you got to do it. Because you don't want to go through life having somebody think for you. That's not cool. So, last one, letter D, you have on your notes. 3 terms, that's okay. I want to see what's the number that 4, 2, and 6 share. The highest number that they both share, well, that's 2. And like I said, if you're like, where should I get these numbers from? Do the table. All right, just set up a table and you'll see that they all have a 2 in common. Now, I have an x cubed, x squared, and an x. The GCF of the variable will be the lowest exponent. That's your x. So the GCF between these 3 terms is just 2x. Now, what we did here was literally a timeout in Algebra 1 to review GCFs. I had to do this because in the next video, we're going to go back to the factoring and we're going to see how this comes into play because you got to factor the polynomial in order to solve it. So that's the next video. We're going to start with factoring out a monomial and then we're going to see how we have to take the GCF